So in our last video, we learned how to divide polynomials, just basically setting them up, dividing them right there. And we talked about the most common mistake that you would see, and that's when basically when you're doing your subtraction, kids make negative sign mistakes. Very easy to do, but very commonplace for error. The second most common mistake, like the other big thing that kids will do wrong, is on a problem like this one. So I want to go ahead and show you first of all, with magic numbers, how this problem works. So if you were to do your factoring, your magic numbers on this one, this is the same thing as x squared plus 0x minus 16. And I know I can do this pretty fast up here. I just want to show you the answer. You can check this yourself and verify that it works. But if you do your factoring on this, the top turns into x plus 4 times x minus 4. And the bottom turns into x plus 4. So since we have matching x plus 4s, those cancel. We just get x minus 4 for our answer here. That's what we're shooting towards. That's the actual answer to this problem. But I will see kids all the time mess up this sort of problem using the same division process they just learned. First of all, let me show you why this doesn't work. The most common thing you'll see. People will set it up like this. When you go to do your division, it starts out just fine. We get x squared plus 4x. But you hit a wall almost immediately. If you look right here, we have to subtract now. But we have x squared minus x squared. That's fine. How do you subtract these two? It's like it doesn't even make sense. They're not like terms. You can't subtract them and go on with the process. So that's not a very ideal way of doing this. The reason this one is different here, if you didn't see it, is that if you look at it, there's no x term in this one. That middle piece right there, where we would normally have like a plus 4x or something like that, isn't there. So what you need to do on a problem like this, and I actually want you guys to write this down in your notes. I promise to put a 0 for any missing terms. If you don't put in that spot, like the 0 anyway to make a placeholder, you're going to get the wrong answer. So any missing terms, you're going to put in a 0. And I'll show you what that means in the problem in just a second. So make sure you write that down. Promise to yourself that that's going to happen because it's a very common place where kids will mess up. So, want to go ahead now and show you how you will actually do this problem. You still set it up the same way. Got our x plus 4. On the outside, we're going to do x squared, but I'm going to throw in a plus 0x right here as a placeholder so I still have my x term. So I throw in my 0x because I was missing it. If I had like an extra third thing, like I had a cubic polynomial, but I didn't have an x squared term, I would put a 0. Any pieces that are missing get a 0. That's important. And now we just divide it like normal. X up here, you multiply it in, you get x squared plus 4x. When you subtract, you get negative 4x. You bring down your negative 16, and the problem works just like normal. You end up subtracting them. This one has no remainder, and you do get x minus 4 like you were supposed to. So the key thing here is this little guy in the middle. That was necessary to do the problem. You have to make sure you put in the missing piece. So I'd like you to try this one for yourself. Pause the video right now. If you want to see the answer first, I will move it in just a second. But pause it now if you don't want it spoiled for you. I'm going to go ahead and move the answer. Correct answer to this problem is written right there. And I'm just going to quickly show you guys how that works. This is the first time we've had a number other than just plain old x, where we've had a coefficient other than 1 in front of it. But it works the same way. Just don't forget to put your plus 0x in there since we're missing that middle term. And when you actually multiply it in, again, I'm moving fairly fast to this one, you can see how the work is starting to play out. The 2 just changes how you multiply. We do negative 6 right there. And you multiply it in. You're going to end up with a remainder of negative 2. So I'm going to go ahead and put a plus. Remember, the remainder goes up top, thing you divided by in the bottom. And if you wanted to, instead of writing plus a negative 2, you could just change this up here. It's this exact same thing if you were to make this minus that fraction with a regular 2. So that's our answer for this one. Now, final problem in the video. If you're feeling ambitious, you can go ahead and try this one out. But we haven't talked about one where you do have a cubic polynomial, or a higher degree. Everything so far has been a quadratic on top, but there's nothing that says you can't have bigger polynomials. The process works the same. So anyway, here's the answer if you did try it on your own. And let me go ahead and set it up the exact same way. The nice thing about this process, once you learn it, it stays the same. We're still doing our normal setup. There's just more pieces on the inside. So we look and see how many times does 3x go into 9x cubed, or 3x times what equals 9x cubed? Answer to that is going to be 3, and I need 2 more x's, so it's x squared. When you multiply that in, you get this for your line that you're subtracting. And when you subtract, you end up with negative 21x squared, and you bring down your next term. Now we look to see 3x times what gives me negative 21x squared. That'll be a negative 7x. When you multiply it in, you get negative 21x squared minus 7x. And when you subtract right here, these cancel. Negative 1 minus negative 7, same thing as negative 1 plus 7, 6x plus 2. So we look one more time. 3x times positive 2 equals 6x. We get a 2 right here. And it turns out this one has no remainder. A remainder of 0, so it goes in evenly. If you multiply 3x plus 1 times my part up here, you will get back to your original answer. And that's polynomial long division.